At this point, you've watched a video about how to assign those oxidation numbers, so now we're going to go through several examples. In our first one, we have potassium chloride, KCl. So following those rules, K, or potassium, is in that first group on the periodic table, and it likes to have that +1 charge. And then Cl, or chlorine, that is one of our halogens, and it tends to like to have that -1 charge. So notice when you add these together, +1 -1 will get you a total of 0, which is perfect because that's the charge on the overall compound. Our next one, we have magnesium here. It's part of that second group. It likes to have a +2 charge. And then we have oxygen that will almost always have a -2 charge. So again, these balance out. +2 -2 will equal to 0. Our next one, we have carbon monoxide. Again, O likes to have that -2 charge. We said O always has -2 as its oxidation number, unless it's part of a peroxide. So in this case, carbon will have to have +2 in order to balance it out and equal to 0. Our next couple of examples, I want to make sure that you are paying attention to those subscripts. So notice here, when it says NH3, that tells us we have 1 nitrogen, but we have 3 hydrogens. So hydrogen likes to have a +1 charge whenever it's paired with a nonmetal, so +1. But because there's 3 hydrogens, they each have a +1 for an oxidation number. So +1 times 3 would be equal to +3. So in order to balance that out, since this is neutral, then we know that nitrogen has to have a -3. So notice that -3 + 1 times those 3, there's that subscript, will equal to 0. Same thing for our next one. We have CaC2. Remember, calcium likes to have that +2 charge. It's in that second group, so we know that that is +2. And so we know that carbon has to be -2. But again, pay attention to those subscripts. Because there's 2 carbons, we divide that -2 across 2 carbons. So each carbon has an oxidation number of -1. So +2 -1 times that 2, there's that subscript, is equal to 0. And then another rule that we had talked about, polyatomic ions, we have to remember the charge. So notice that this has an overall charge of -1. So the total is going to add up to -1. So in this case, again, we have oxygen that likes to have that -2 oxidation number. So we went ahead and wrote that in. But because it is -2 times 2, because that's subscript, there's 2 oxygens, then we know that something -4 has to equal -1. So 3 minus 4 equals that -1, which means nitrogen has that oxidation number of +3. And they can get a little bit more complex. Our next one down here, we have 3 different elements involved, but the rules still apply. So in this case, our hydrogen, again, likes to have that +1 charge unless it is with a metal. So +1, and then we know our oxygen has -2 unless it's in a peroxide. So we know that +1 plus something else, -2 times that 3 will equal to 0. So basically +1 minus 6. So what should we add in order to balance that out to equal 0 overall? We would have to add 5. The reason for that is you have +1 plus 5. So now we have a total of +6. And then -6 is equal to 0. These are sort of like a puzzle. You just have to figure out the numbers that work to add up to that total that you are aiming for. So this one right here is a little bit different. We have ZnH2. Notice that we have a metal. So because that is a metal, hydrogen likes to have a -1 charge. This is the only time hydrogen will be -1 instead of +1 is when it's with a metal. So hydrogen has a -1 charge, but there are 2 hydrogens present. So overall, hydrogen has -2. To balance that out to equal 0, we know that this zinc will have to be +2. All right, and for our last example, we're going to talk about a case where a halogen, in this case bromine, is paired with oxygen. Remember we said that your halogens like to have a -1 charge unless it is paired with oxygen, in which case it will be positive. So in this case, oxygen, we know it likes to be -2, so -2 times 3, so this oxygen is -6. The overall charge is -1, so remember that needs to be on the other side of the equation. So we need something -6 is equal to -1. So in this case, bromine would be +5.